First is definition of power. Power is the rate at which work is completed. It is also defined as time rate of doing work or delivering energy, expressed as work done or energy transferred divided by time interval. The formula for power is work done over time. Then the SI unit for power is the watt, because it refers to the rate of working. 1 watt is also equals to 1 joule per second. It is because work is energy transfer, while power is the rate at which energy is expended.
Application of power in our daily life. We use lamp every day to illuminate a dark room. One day, a waste of electricity has occurred because a 150-watt lamp is left open for 30 minutes. So, to calculate the waste of electricity, we need to use formula E equal to PT, where E is change in energy. So, E equal to 150 times in bracket 30 times 60, because minute need to be converted to seconds. Then we will get the value of electricity wasted, which is 270,000 joule.
Next application of power in daily life is when someone climbs upstairs. As we know, the formula for power is P equal to W over T, which is power equal work over time. Since work can be written as force times displacement, power can also be written as force times displacement over time. So to calculate the power when someone climbs upstairs is we need to divide the work they do divide the time it took for them to go up the stairs, or we can calculate by measure their force multiplied by displacement over times.
Question. A man pulls a trolley filled with coconuts using 65 Newton of force for 8 meters in 3 minutes. Then calculate the man's power. To find power, we need to use P equal W over T formula, where W is work and T is time. But we need to find work first because we are given distance and force. To find work, we use W equal to Fs formula. So, we need to multiply force and distance. Then, the value of work is 520 joule. Next, we replace the value of work into the P equal to W over T formula to find the value of power. Need to remember that time must be in seconds. So, 3 minutes is converted to 180 seconds. So, P equal to 520 over 180. Finally, the value of power is 2.89 watt.
Question. In a snatch event of a weightlifting competition, a weightlifting lift 140 kg from the floor to a height of 1.8 meter above the floor in one complete movement in a time of 0.7 seconds. What is the power generated by the weightlifter during this time? From the question above, we can rewrite the information that we get. So, from the question, we get information about mass, displacement, and times, which is mass equal to 140 kg, displacement equal to 1.8 meter, and times equal to 0.7 second. From the information, we can use formula power equal to mgs over T. We just substitute value that we got. 140 times 9.81 as a gravity times 1.8 over 0.7. So we just use calculator and we get 3232 watt.
The question is, every day of school, Faiz needs to use the staircase to go to the classroom, since it is on the 3rd floor of the building. So he walks up the staircase of 30 meters with a force of 800 Newton in order to get to the classroom. The question is, calculate the power consumed by Faiz if the time taken to get to the classroom is 7 minutes. We use formula power equal to work done over time. Work done is equal to 800 Newton times 30 meter. equals to 24,000 Newton meter and also the same as 24,000 joule. The time is 7 minutes times 60 equal to 420 seconds. So to find power, it is 24,000 joule divided by 420 seconds equal to 57.14 joule per second, which is the same as 57.14 watt.
So, the conclusion is, we can conclude that power is the result of work over time. Other than P equal to W over T, power can also be calculated using the formula P equal to force times displacement over time, because work equal to force times displacement. The higher the power of an object, the more powerful the object. Besides, that power also can be calculated using P equal to E over T, where E is the energy transfer and does not involve any force, while P equal to W over T is used when there is a force involved. So the unit of power is joule over second or watt.